Yesterday and on Monday. So now we're going to go over the expected value of a probability distribution and the standard deviation. So probability distributions are often used to analyze financial data. The two most common statistics used to analyze a discrete probability distribution are the mean or expected value and the standard deviation. The expected value, E of x, of a discrete random variable of a probability distribution is the weighted average of that variable. So to find our expected value, the expected value of a discrete random variable is the weighted average of the values of that variable. It is calculated by finding the sum of the products of every possible x value and its associated probability. So to find expected value, we're going to take the sum. Okay, that's what this means right here. Okay, that's the sum of our x value times its probability. Where are you going? To answer a phone call.
It doesn't matter, he doesn't listen anyway.
All right, so we are going to, in example 1, find the expected value for this chart here. So Kurt won a ticket for a prize. The distribution of the values of the tickets and their frequencies are shown. We want to find the expected value of his winning. Okay, so to find our expected value, again, we're taking the sum of x times the probability. Now your x values are this top row here where it says value in dollars. Okay, so that's your x. And then we have our frequency. Now recall from our probability distribution charts that we made, we used the frequency to find the probability. Okay, so to find that probability, we will have to add up all of these frequencies. So 5,000 plus 100 plus 25 plus 5 plus 1 plus 1. Okay, so
5,132.
It is 5,132. So before we start finding the expected value, you can find the probability of each case, or we can just enter it in as a fraction for p of x. So we need to take x, which is 1, okay, multiplied by the probability. So to find our probability, all we have to do is take our frequency, which is 5,000, and divide by our total of our frequency here. So 5,132. Okay, so that was that first one. Okay, now again, this symbol means sum, so that means I have to add on the next one. So our next value for x is 10, so I'll plug in 10, times that probability. So my frequency this time is 100 over my total. Okay, again, that was the second one. Move on to the third one. So we're adding each time. Okay, you're adding every single value together. So our next x value is 100 times its frequency, 25, over the total frequency, 5,132. Next value is 1,000 times that probability was 5 over 5,132. Our next x value is 5,000. Okay, our frequency there was 1 out of 5,132. And then the last one is 25,000. And again, that frequency is 1 out of the total, 5,132. Okay, so if, again, instead you don't want to write it as a fraction and you'd rather use that decimal, find that probability first, you can. So to find that probability, again, you just take your frequency, divide by the total. You can get that decimal, and instead of plugging in the fraction, you plug in that decimal to multiply by it. Okay? So from here, all we have to do is take a calculator and find this. So I don't know if you guys have a calculator or not. But what I would do, sorry, I don't know where my other calculator is, so I'm going to use a graphing calculator. So this is 1 times this quantity, so I'm not even going to write in the 1. I'm just going to write in the quantity, so I want a parenthesis around it. Then 5,000 divided by 5,132, and end my parenthesis. Okay? So I want to keep those fractions in parentheses. Okay, then add 10. Again, add in my parenthesis here of 100 over 5,132. End my parenthesis. Same thing with 100 and so on here. Okay, so you have to be careful when you enter this into a calculator. Otherwise, you will get the wrong answer. And I would make sure you can enter this in your calculator. So if you're not, you should. Okay, when I finished entering everything into my calculator, I get my expected value to be about 8.48. Okay, so make sure you are able to type that into your calculator to get 8.48. So the expected value of his winnings would be about $8.48. Okay, so you're just using this formula to help you find that expected value. So again, that sigma in the front, this E-looking symbol, it's called a sigma. It means sum. That means you have to take each one and add it together. Okay? So, questions on that first example? All right, then example 2. A tetrahedral dice has 4 sides numbered 1, 2, 3, and 4. We want to find the expected value of one roll of this die. So we are just finding the expected value again. Okay, so to find our expected value, again we're finding the sum of x times p of x. So with this one, since it only has 4 sides, those are 4 x values, 1, 2, 3, and 4. Okay, so if you need to make out a small chart here, so you know. Shh. Quiet, please. Okay, our x values in this case are numbered sides, 1, 2, 3, and 4. What is the probability that it lands on 1? If it's a 4-sided die, 1 out of 4. Okay, what's the probability it lands on 2?
1 out of 4.
1 out of 4. Okay, so you have 1 out of 4 chances that it lands on any of those numbers. So now that I know what x and p of x are, I can find that expected value. So need my first x value is 1, multiplied by the probability is 1/4. Okay, add on the next x value, 2, times its probability, 1/4, plus our next x value is 3, times that probability of 1/4, and then the last one is 4, times that probability of 1/4. Okay, again, you can enter this into your calculator. What? Yeah. It is 2.5 or 2.5. All right, questions on finding that expected value? Because next we're going to find this standard deviation. All right, so on the back here, sometimes the expected value does not provide enough information to fully analyze a probability distribution. For example, suppose 2 wheels had roughly the same expected value. Which one would you choose? Which one is riskier? The standard deviation can provide more insight into the expected value of a probability distribution. So the formula for calculating the standard deviation of a probability distribution is similar to the one used for a data set. So here, to find the variance, remember we had to find the variance before we found the standard deviation. That's sigma squared. That's equal to the sum of your x value minus your expected value squared times your probability. Okay, then to find the standard deviation, all you have to do is take the square root of that variance that you found. Okay, so it'll look a little bit easier once we go through this example here. So at a raffle, 400 tickets are sold for $1 each. 1 ticket wins $100. 5 tickets wins $10, and 10 tickets win $5. Calculate the expected value and standard deviation of the distribution of winnings for a $1 ticket. So just like before, I'm going to make a chart for x and the probability of x. Okay, so our x values are the dollar amount that you win. Okay, so the x values are the dollar amounts that you win. So we have $100 as one winning ticket. Okay, we have $10 for another winning, and $5 for that one winning. Okay, now what's the probability of 100? Well, only one ticket wins $100, and there's 400 total. Okay, so one ticket out of 400 win 100. How many tickets win? Okay. Now, remember when I talked about finding the probability, when you add them all together, it has to equal 1, right? Yeah. If I add all 3 of these together, does that equal 1? No. So the last x value that you need is this minus 1, because those people are losing $1. Okay, because they paid $1 to be entered into this raffle, but then they didn't win anything. So how many people didn't win anything? Yes. Okay, so 384 out of 400 lost $1.
Sucks.
Okay, so next, in order to calculate the standard deviation, we need to first find the expected value. Okay, so just like what we did on the front, we're finding the expected value of x. So to do that, we need to take that x value, which is 100, multiplied by its probability, so 1 over 400, then add on the rest. So plus our x value of 10 times its probability, 5 over 400, plus 5 times that probability of 10 over 400. Okay, then plus this negative 1. Yes, it has to be a negative 1 because you're losing that $1. Times 384 over 400. Okay, so again, all you have to do is enter that into your calculator. Again, being careful with those parentheses as you enter it in that calculator. You should get negative 0.5 or negative 1/2. Okay, now to calculate the standard deviation or variance, first we have to calculate the variance. That's this one up here. Okay, so again, we have this symbol here that means sum. We need to take our x value, subtract our expected value, which we just found, square it, and then multiply by the probability of that x value. So our variance is considered sigma squared. Okay, and it will be equal to, again, the sum of, I'm just writing the formula, x, okay, minus, what was e of x? What's our e of x value? Negative 0.5. So we're going to subtract negative 0.5, square it, and then multiply by p of x. Okay, so again, we just have to plug in our x value and our probability into this formula here. So our first x value is 100. Okay, so we have 100 minus that negative 0.5, that quantity squared. And then what was the probability of 100? 1 out of 400. Yep, and we're adding because this is that sum symbol. So we have to add each one. So our next x value is 10. We're subtracting a negative 0.5 and squaring it. Then multiplying by the probability of winning $10, which is 5 out of 400. Okay, plus our next x value is 5. Subtract our expected value was negative 0.5. That quantity squared. Then multiplied by the probability of winning $5 was 10 out of 400. Then the last one, our last x value is negative 1 minus negative 0.5 squared times its probability was 384 over 400. Okay, now you could enter all this into the calculator at once, but I'd be really careful doing that. If you want to, first what I would do is find what this quantity is and square it, write that down, and then multiply by that probability, which is 1 over 400. Okay, so when you do enter all of this in your calculator, you do get a variance of 27.625. Okay, now again, that's the variance. If I look up top in that table, how do I find the standard deviation then of that variance? Yeah. Okay, so since this is sigma squared here, to find the standard deviation, which is just sigma, you have to take the square root of that variance. Okay, so I'm taking the square root of 27.625. Get a standard deviation of 5.26. Now, if your standard deviation is a larger number, that means it's going to be riskier. So on your assignment, I do have one where you're comparing two winnings. So if one of those standard deviations is higher than the other, that's the riskier case, okay, because you have more variability between winnings, okay? Any questions on how I found the expected value, the variance, or the standard deviation? You're just using this formula.